Testing audio. Testing audio. All right, guys. We're gonna give people we're gonna give people another 5 minutes or so to come in, and then we'll go ahead and start the workshop.
Okay.
All right. Hello. Okay. Hello, everybody. Welcome to our computer vision workshop. Let me get the PowerPoint real quick. So there we go. All right. So, computer vision, I'm pretty sure y'all can guess what that means. Computers looking at images and recognizing what the heck is this, right? Pretty simple. So to begin, right, I am Mark Bryant.
I'm Aishwarya. Sorry.
Yeah.
Can you make sure y'all's audio is working?
We
It
checked
is.
the audio, yeah, don't worry.
Good.
So how many of y'all are freshman or sophomore? Or show of hands. All right, nice. Yeah. So this workshop is kind of supposed to be beginner friendly for all of you who aren't absolute god tier genius programmers. So with like the AWS, the SageMaker buzzword, right? So we're just doing like Google Colab, Jupyter Notebook, you know. So let's get right into it.
All right. Thank you again for everyone who came out for this workshop. I'm just going to introduce what we are going to be going over today. So we're going to start off with the goal of our machine learning model. So essentially, the biggest part of a machine learning model is determining what your end goal is. And so we're going to define that at the very beginning. And then we're going to go into data sets and talk about why sizing of data sets is important, like how to pick your data, and depending on like your project, how to determine what type of data set to use. Then we're also going to talk about the libraries we use, go over some common libraries that you should be familiar with or learn about because, again, they're used in a lot of machine learning models. We'll talk about training and testing data, and then finally go through a walkthrough of some code.
Yay, demo. Oh yeah, you're still going. Yeah. Okay.
Okay, so the goal of our project today is to build a machine learning model where we're going to classify images of houses, which are one-story houses and two-story houses. So this will be a binary classification project using AI and computer vision. So let's talk about data sets. We did link the data set we've been using for our model today, but to talk about the importance of a data set, it's probably the most important factor of your project, if not one of the most important. So finding a data set, you typically want to use public data sets so you don't get copyright or like you don't mess with any private data sets. So places where you can find public data sets, Kaggle, UCI Machine Learning Repository, and Google Dataset Search. And your size of your data set. So depending on what you're trying to achieve, what you're trying to solve, the size matters. Typically, the larger the data set, the better because you'll have a higher accuracy. But again, depending on the diversity of the data set, how you're trying to classify it, and what type of libraries you're using, your size of your data set, what your most efficient size should be, will vary. Okay, so here are a list of the common libraries. We're not really going to go over them in detail because we will talk about them when they're used in our code. However, these are very common libraries that are used in basic machine learning models, advanced machine learning models, so they're good to know. So when you do get access to this reporting in PowerPoint, you should take a look at them if you don't. Okay, and next, convolutional neural networks. So this is what the biggest part of our workshop is going to be about today. What does a CNN do? So a CNN is essentially used for image and video recognition tasks. And we use them to classify using detection. So it'll detect objects or it'll use recognition and like analyze the different images you have or videos to be able to put it into a classification. I'm going to hand it over to Mark to go more in depth on that.
Thank you, Aishwarya, for that. Appreciate it. All right, so again, like you said, we'll go over how exactly does a convolutional neural network work? Right? See, how does it recognize that Zuckerberg over here has a face that's this big, right? So let's see. So a convolutional neural network, the way it works is because when you have an image, it's like a matrix, right? You have an X and a Y grid of pixels, right? And so how do you determine what those pixels mean? So just like humans and neural networks, the way it works is it looks for pattern recognition. And you can see in the image here, there's like a few patterns looking at images. And so it just goes through each little box in the matrix and it like slides across and it says, okay, what is here? Is there a line? Is there a circle? And it applies these things called filters or kernels over it. And when it does that, it'll say, okay, and it records like, okay, these features are here, these features are here. And then it'll do a thing called max pooling, which essentially, this is really oversimplified, but it's kind of like blurring it a little bit, making it like less detail, and then it zooms out. So like, let's say if you're looking at a dog or something, right? Instead of like the texture of the fur, when you zoom out, maybe you'll look at, is there like a line here? Like if you see the ear, like you don't care whether the ear is fur, but you care about like, okay, the ear has a round shape, right? And then you zoom out some more and you say, okay, well, the whole head is a circle, right? So that kind of thing. And then finally, you'll do some of that. You'll do feature extraction. You'll slide over everywhere in the image at different levels of zoom. And then that's where you store the model. And then once you store the model, you can use it to go over everything. And the part you've all been waiting for, the demo. And we'll go through step by step what all of this is. And hopefully you can apply some of it to your machine learning projects at the hackathon here. So if you all just want to take a look at the QR code, pull it up. I'll give you all a minute or so to do that. Get the link across to your computer for the Google Colab. Oh yeah, so Aishwarya kindly reminded me that this takes you to the GitHub page. Yeah. So when you do get to the GitHub page, are y'all good with the QR code? Y'all got it? Okay.
There's a chat.
Yes.
Okay, you'll share the link. All right. And this is like a relatively short URL, github.com, MF25. It's my initials and then my graduation year. Wow. And then house classification. Yeah. So what you want to do when you get here is you click the demo, and that'll get you to starter code. And then you want to get to these different image data sets. So what we did is we took a Kaggle data set and then we manually labeled it 1,000 images. Really 1,000 is like, it seems like a lot, but it's not a whole bunch when you're talking about machine learning. Like there have been competitions before where people use like 60,000 images plus, right? And it took us about like 2 hours to label it, so it wasn't too bad. So let's go to it. So you see these images here, right? Fancy. And then you're going to want to, you'll see them here in your drive. And then you'll see them in shared with me. And so what you want to do, you want to download them like that. And you want to do it for both folders. So let's see. Oh, there it is. There's the downloading. Downloaded. And then you will go to your Colab. Are y'all good with me up to this point? Are y'all getting the files? You're good? Okay, nobody's saying anything, so I'll assume that you're all perfect and you know exactly what you're doing. So once you're in Colab, you'll see this option to upload files. And you just select it from wherever. And you'll upload it. And hopefully you'll extract them. Don't do the zip file. For me, since I already have it, I'm just gonna upload it real quick. No, I'll do the other version. I'll do what y'all are doing. And if any of y'all have questions, feel free to raise your hand and ask. Yeah, good point. So when you do have these, you want to have the names as 1_story and 2_story with capital S, by the way. Because what it does is it takes it from the directory with the name to tell. That's very important. And then now once you do that, we upload. Application here. So are all of y'all on the same page? Gotta give a thumbs up for any of you who are really good with this? Okay.
I'm ready to go.
No. Yeah, I know. I can do that. Oh, yeah, I apologize for the technical difficulties. No, I guess our browser is smart. It remembers that we have stuff uploaded. What?
Make a copy
what is the package backlog?
Right, so thanks for the question. Yes, what do these packages do? So what they do, these are just basic. So this is like math. This one, PyPlot, you can kind of tell from the name that it lets you visualize data and plot it. And we're going to do that. That way you can sort of understand what you're doing. TensorFlow and Keras are super popular AI models. Or model packages, you could say, that we're using in this workshop. This metrics will let you sort of evaluate how good your model is doing. And this is for getting the files, which is what we're going to be juggling with right now. Yes?
I have a question.
Sure.
So can you explain what all those layers mean? Like the DAGs, convolutional 2D maximals, real quick?
Yeah. I can go into a little bit, but we will go over some of that in the code. Yeah, we'll go over it on the code. Let's try this again. We'll try this right now. I feel like red is not a good color. Wait, what? Oh, yeah. Okay. What?
Going to the
This? Oh, wait. Oh, okay. There we go. And yeah, so another thing you'll realize when you start working with AI and other complicated technologies is that they don't always work how you want them to. And you will have to sort of figure out from like documentation and things like that and play around with it. Okay, we finally got it in the folder. All right, so now we'll just do it again and then we'll be ready. Again, sorry for the wait, the technical difficulty here.
And if anyone else is having trouble with uploading their files, I can help with it.
Otherwise, I'm not creating the folder.
Oh.
It's not creating the folder.
It's pretty intense. You can't check.
Yeah.
Oh, thanks. Oh,
Oh, okay, sure. This is bad. Alright, so once this is done, we'll finally be able to go into the actual code. Yes, sir.
Why is a convolutional neural network called convolutional? What makes it convolutional? Is that
Right, good question. So we asked, what is the convolution part of a convolutional neural network? So convolve essentially is like a technical term that describes when the image reader goes through all the different parts of the image. That's called convolving around the image. All right, okay, so we finally got our files after a little bit of difficulty here. Okay, so like I explained earlier, this is all of our libraries, and feel free to look up like the documentation for these libraries, specifically TensorFlow and Keras. Those are the main AI ones that we're looking at. And then this is the part that imports those files into the actual code. So if you want to just run that and run this. Click on them. And then while it's, oh, there you go, mounted to track. All right, so now you have these labels here. And what that does is it's like an array, and you're putting the images into these arrays with these labels, 1 story and 2 story. And you want to set a variable called image size to say this is 100 by 100 image. So it's standardized, and we picked a relatively small image because we don't necessarily care about like the fine texture of like the brick, like the 575th brick of the house, right? We don't care about that. We just care about the general shape, like how many windows it has. So we don't need it to be too large of a file size. And then here, you have this code already, so you don't need to fill anything later. Yes, sir.
What does Keras do? Like you import Keras, right?
Right. So again, we'll go through that later in the code. We haven't gotten to that part yet. Right now, we're still sort of grabbing our data, and then we'll look at using AI to like analyze it and stuff like that. But for now, get data. This is all, you can just copy paste this code really. This isn't like super complicated or anything. You have a loop that goes, you have a loop that just goes through the directory and just appends the files into an array. And because Python is cool, you can just have a data type of whatever. And you guys can run that. Here we get the data, the images. And so you see this code here. There we go. And let me fill in for you what that is. So you want to do train. Y'all can hear this? No. No, it's okay. I mean, we tested before that the mic isn't necessary anyway, so I'll just talk a little bit louder. Yeah, it's fine. No, it's fine. Huh? No, it's okay. I'll just talk. I'm good. All right. Y'all can hear me, right? Okay. Yeah, so you want to have train, and then you want to have NP, which is our NumPy library, dot append. And then we have this images array, and I'm going to do images 350. And images all the way to 650 onward. So what this does is, since we have 1,000 images, we take, that would help. So we take the first 350 and then the last part of it, and that's how we split it, because they're ordered, so it's like in the middle, right? So we have an even distribution of 1-story and 2-story houses into our training data set. And then what you want to do, you want to get your test data. So you test equals images 350 to 650. So that's the inside part. All right. Did y'all get that? Okay. Cool. And then here, now we're going to test that what we did works. You want to always sort of test what you're doing, like as you go along, so you make sure that it works and you're not like all the way like super deep into the code, and then you have to look at this big block and then not have any idea of which part of the block is the error, right? So let's test. So we're going to do PLT, which is our nickname for the pie plot for the visualization. So plt.figure, we call the function fig size equals 5 by 5. And then after this, after we set the size of the print statement, we will plt.show. This is the actual showing and printing. You want to do plt.show image, images. Gosh, I'm so bad today. 350 to there you go. I have my laptop here as a reference for me because, you know, memorizing code. So it's running to get the data, and then as soon as all this finishes, we'll have one of the images printed out, the 600th image in the data set. Oh no, what did we do? Right, I see.
It's the tree.
Oh, it's image. Oh, it's that. Yeah. I'm not doing very good with spot the difference in real time today. All right, so we have an image here of a house. For us, we can clearly see that it's a 2-story house, and we'll see later how our AI does with these houses, right? So the next piece of code, are y'all good? I see y'all are collaborating over there. Y'all helping each other out. Y'all are good? Okay. So you have these arrays here, because we have training data and testing data. And so the X is sort of our features, and then the Y is the part that we're after of whether it's a 1 or a 0 or like 1-story or 2-story. And then we have the same thing for the testing data. Yes, sir.
You know the difference between testing and data.
Say that again?
You like know the difference between testing and data.
Right. Yeah, I explained that. Okay, my bad. So the training data, when you have a data set, you always want to split the data set. So we have 1,000 images, right? So we're going to train the model on 700 of those images, and then we're going to validate it against the last 300 of them, because you don't want to test it on the same data that you trained it on, right? Because then it'll sort of just like memorize the data, right? Like then it's not really like learning anything, right? And what they call that is overfitting generally. So that's what that is. So after that, this is just the loops to like go through and add them. Fairly simple. And this is just to This code is just to get it into this shape so that the libraries can read it. So if you just do that real quick, it's fairly simple. This code right here, this is just another one of those blocks of code that you can just copy paste. What this does, you can see image data generator. You have your images and you don't know how wacky they're going to be. So you want to sort of shift around, like zoom them, rotate them, so that way your AI is resilient and robust with any sort of difficult input data. So you go here and you train and you add that real quick, and then it manipulates your image. So now we're at some more code, and now we're at the AI model part. Yes, sir.
With that last code segment,
Yes.
so you're just like, you're talking like zooming in and like zooming out, and
Right.
doing different things to the images that you already have. Are you making more training data? Is that what you're doing? Like, what is that?
We're manipulating our data a little bit, and so it's essentially like random. And so like you see rotation range, that's like 10 degrees a little bit, and so that tells you like it'll randomly go through all the images and randomly choose anywhere between like a negative 10 degree offset to a 10 degree offset. So that, just to make it like more robust and like you don't know exactly, right? Like be prepared for anything, right?
But that's like editing the data that it's training and testing on?
Right, it's a little bit, yeah. That is, yeah. Yes, sir.
You gonna be posting the code for this later?
Yes.
Yes, we will be posting the code later. It'll be on the GitHub. Right now, the GitHub has the starter code, but we'll switch it later. Yeah. All right. So the next line, what you have is you want to get, hold on. So you're going to create your model. Model equals sequential. And so what this does is it creates an instance of an AI model using the TensorFlow sequential API. This one's like simpler, and what you'll do if you want to get like more advanced, you'll do the function version, but for this workshop, we'll just do the sequential. And then after you create the model, you want to do model.add, and we're going to be adding a convolutional layer to it, the fancy image processing one, right? So conv 2D, and then you do 32 3D heading equals num activation equals ReLU, put shape equals all right. Oh, yeah, there you go. That's it. Okay, so what this does, right? So padding, what that does is, so we have all these images that we import, right? And we say the size is 100. And so what this padding is essentially, if your images are like a little bit different shapes, then it'll sort of just add extra like blanks pixels at the end of it. That way, like if it isn't a multiple, like if you're scrolling through like a 3x3 matrix all the way through the image, and it happens to not be a multiple of 3, it'll just add something to make it work, right? So then this activation function, that's like an AI thing. And if you ever take any classes, you'll go over this. ReLU basically just, it's kind of like when you have negative numbers for your, I guess your error, it'll sort of just take it and it'll make it 0. Because like if you do like linear regression, I'm sure y'all have heard of that. It like tries to fit a line. And that's just one of those things. You'll learn about it. and then input shape, y'all can figure that out. It's the shape of the image, right? And then this is the pooling that I was telling y'all about in the slides. That's like when you like sort of combine, like pool some of the features, the pixels. We add another one of these, another one. Dropout essentially drops random parts of the data set as you train it. So that way, again, you're not memorizing or overfitting the data. And then this last part with the flatten and the dense, that just converts like the image style neural network back to like a normal neural network. And then this will show sort of what it is. You see, we got quite a lot of parameters here, right? Lots of stuff going on. So did you all get that? Y'all kind of understand a little bit? Okay. Again, any questions, just let me know. So now we're going to go over sort of what the specifications of the model are a little bit. So for the code here, what you're going to want to do is you're going to do opt, which is short for optimizer, equals Atom, and then LR is the learning rate. So if you have a high learning rate, it'll figure things out faster, but you have a chance of like overshooting, like this versus just like, you know, equals 0.001. So that's just a parameter. This is more stuff for evaluating the model, compiling. So what this does is when it detects that it's overfitting, it'll stop. And these are all more parameters, like you evaluate based on accuracy. And this basically is the function for how it's going to detect like whether your model just got better or worse when it's like making the little tweaks as it goes through the data. Because that's what it does, right? The model, it goes through the data and it sets like random parameters, and then it adjusts them based on how well it did, like the performance of the data. So it's going to keep doing that and use like the loss and the accuracy to evaluate it. As there you go, you have it. All right, so for actually training the model, this is the part that normally takes a little bit of time. So what you're going to want to do is you're going to do history equals model.fit. And you'll see that a lot. Model.fit, that's essentially just like training your model to fit the data set, right? So you do xtrain, comma, ytrain, box is 20. This tells you how long it's going to train for. Initial box equals 0. Validation data equals x test. Right. That's what you're using to evaluate your data on. And finally, this is just another parameter. Callbacks equals early. All right. And then what?
Callbacks.
Callbacks. Thank you. Yeah. And then when you press play here, it'll start training the model, but we already have the model. Y'all can do this later, but so you can just load the model. Again, it's on our GitHub. If you click on our model, and you'll just download it. So you go up, and then our model, download. exhibit.
What did Flat get rid of earlier? I know we did.
Oh, Flat.
Trained it.
Yes.
I know that we trained it and then we flagged it to get rid of something, but obviously that's not.
No, the flatten essentially takes it from like the image style neural network and then puts it back to like a normal, like an average normal network. That's just a thing that you do with computer vision. Don't think about it too hard. Yeah. So let's see where we sit. Showing folder. Extract. Oh my gosh. As class model. So right now we're uploading our model because we already trained it ahead of the workshop because it takes maybe like 20 minutes or so. So AI does take a lot of time. So now we're just going to do model.load instead of the training we have here. Check mark. And then now we're going to get our test images. And again, back to the try that we all love so much. Download. And another thing you'll learn when you do AI is that there's a difference between the free software and the software you pay for. And so you're seeing the free software here. All right, so here we go. We finally have our test images and we're gonna get to see some stuff. So we have this function. This is like copy paste from above, essentially. So we're gonna go through and we're gonna do predictions equals model.predict and then images 2. And that's our images right here that we just added, which is just 10 images just to see how we did for ourselves. And you go here, and then we're gonna print how we did, or print our images. The next one is the final print. You go, and it prints it. And there you go. All right, and you see, all right, what are these ones and zeros everywhere? These are random numbers. So that's classifying it as either a 1 or a 0. And then to put that in readable form, we have a loop to go through all the images, and we're gonna print the image with the PLT figure again. And then we're gonna print the corresponding title. We're gonna set the title to either 1 story or 2 story. And then here, if you want to add, finally, the plt.imshow or images show, images to I, and There you go. We just predicted 10 houses worth of whether they are 1-story or 2-story. Pretty basic stuff, but you know, got to start somewhere. So 2-story, 1-story, we got this correct. 1-story. This one's incorrect. So you'll know probably about 80% is what you want to shoot for. So we got one wrong. 1-story, another one wrong. 1-story, 2-story. So we got the 80% mark that you're looking for. So that's our code. Do y'all have any questions about the code?
What did
Yes.
the numbers mean beforehand? You had like, yeah, those right
These?
there. Yeah.
Right. So this is basically 0 and 1. So it looks like a different number, but like this is a 0 because it's like 0.000 and then like an exponent, and then this is to the negative exponent, right? So it's 10, but it goes back, so it's basically 1, just like 0.99999.
What do those mean though?
That's the classification of whether it's a 1-story or a 2-story, and that's why we have this here. We take the prediction value of this, and then we basically say, okay, well, if the number is like 0 or 1, right? You say if it's greater than the other one, the one that it's more likely to be, we'll say, okay, 1 or a 2-story house, right? So this is like converting it to something that you actually can see what's going on. So yeah, anything else? No? All right, awesome. So again, this code will be available on the GitHub over here. Shortly after the workshop, I will change this to the official notebook. So it'll be a little bit neater and stuff like that. And then again, our images and our pre-trained model that we did, and then the test images that we used at the end. So thank you all for coming.
Thank you for coming.
And good luck with your hackathon projects.